What's the best way of teaching something new? A book, a research paper, or maybe a documentary? But imagine turning your classroom into an abundance of all the real world possibilities. All of that is now possible through PBL, where students learn by actively engaging in real world projects in a meaningful way.
About my experience with PBL, I've had some fair experience with practicing PBL at first year engineering education. You will realize that when I look at connecting courses or connecting modules or integrating learning for students, PBL plays a very important role in achieving this objective. While there's a wide lot of literature on PBL which speaks about the definitions of PBL, its challenges, its do's and don'ts, I would distill PBL into its like by 5 or 6 basic principles. The first one is orienting. For the first one could be a problem, an element of interest that exists around us. It could be why birds fly this way, or why the rainbow occurs in that way, or why do I have to design a system in a given way. So given this particular problem, there's a lot of cohesive content that needs to be served to students. So I just spoke about the first 2 principles of PBL. One is the problem, which is the initiation into teaching and learning, the element that sparks interest. Second one is the content that the student needs to know before attempting a PBL. Then the third element could be, well, I believe that knowledge is socially constructed. So keeping this premise in mind, I would definitely want students to work in teams. So PBL generally works best when we have a team of students integrating their different perspectives, their knowledge to create a solution to a given problem. While we are doing PBL, the entire intention of it is to help students own their learning. This is where the fourth principle comes into picture, which is self-direction or self-regulation. With the entire process of learning, we try to push, I wouldn't say the burden of learning, but the accountability of learning on students, which is actually taking them towards the lifelong learning skill. In the context of all this, the most important thing here would be, I think, it's about identifying the right problems that students can solve. And this is where, I realized that a lot of work has to be done by faculty members. Now, I spoke about the principles of PBL and why they're essential. Then I'm going to talk about the role of faculty members in identifying the problems that students can solve using PBL. This is where the art of balancing the content complexity, the feasibility of solution comes into picture. So a lot of faculty members need to spend immense amount of time in trying to identify case studies or problems that students can take during their courses. Now, if you look at PBL, there is no cookbook for PBL. There are just 5 principles which appear in different degree across different courses. Many of us could be practicing module level PBL, but in module level PBL, the problem I foresee is integration of knowledge across courses. And if all of us had to start doing module level PBLs, the number of case studies we have to curate, the amount of effort every faculty has to put is humongous, and it is very prohibitive. So what I would look for is a course wherein we are integrating knowledge across different courses. Now, for example, if you have a course like, say, I'm from a background in computing, I would talk about computing courses. So if I say software engineering as the key piece in the jigsaw puzzle, I would look at all other courses that are focusing on the requirement of software engineering. It could be a full stack course, it could be a DBMS course, maybe a networking course, something like that. And keeping software engineering principles in mind, that would drive the agenda of this course. And given a real world problem, which actually focuses on all of these courses, I could think of 5 of these faculty members coming together and creating an ecosystem: the content, the assessment and pedagogy. So what was actually 100% effort from 5 faculty members came down to like 20% effort from each faculty member. So you see, PBL has principles. PBL can be practiced at different levels, at a module level, at a singular course level, or a cross course level. So what works best, it depends upon the institute's mandate and its context. So my university right now is focusing on course integration. So I would always look at pitching PBL as a common denominator across courses. So yes, this is where it is. One example could be that if I'm looking at the typical difference between a case and a problem, I think that's the first thing we have to put out there. From my experience and a lot of reading and interacting with key experts in PBL, I realized that Case studies are watered down versions of problems. They remove out the elements that cause uncertainty. If you have like 5 unknown variables, you could just keep like 2-3 unknown variables in a given case, right? So if I have, let's say, like if I have a problem wherein I have to agree mechanization is a problem, right? It is very huge. So if I want to bring this down to attainable level, what would I do? At a first year course, for example, I would just go down and say, why don't you design an equipment that will simply pick up the good fruit from the bad fruit? I don't want the entire umbrella of agri-mechanization, but bring it down to just this, and only for this flower. Let us remove all the uncertainties in there, and let's just do it for this, snipping a flower, or flower A from flower B. So now what was once a very large problem, I have brought it down to the context of a course in which I am teaching how to identify a good flower from a bad flower, and how do I design a mechatronic system that can just snip that thing, right? So it could be an Arduino-based system, an Arduino-based AI system, wherein it has, well, the mechatronics part of it, because I'm looking at, sensing and control and actuation. But I also have intelligence coming in, because I should know how to classify a good flower from a bad flower. That could come from a typical thing like, Google Teachable Machine model or something like that. You could train it. And this can be a black box for students. I don't have to teach them how Arduino works, how a servo works inside, but just its usage. This is one typical example where I would actually, remove the elements from a large agri-mechanization to something as small as a contextual problem required for that course. And the most important part here would be for the faculty members to identify which exact knowledge elements or concepts are required to be implementing this problem, and creating curated learning resources for it, especially at first year or second year of engineering. You see, PBL always needs like 20 to 40% of extra learning on students' part. So as this extra learning increases, motivation dwindles. And there is so much of resources on the internet out there. I wouldn't want my students to spend time trying to aggregate resources like padna kya hai, kya nahi padna hai. So I would use maybe your AI systems or even curate material required just for this course and let them go ahead with it. So here, what was a problem? I brought it down to a simple case application. I also curated content which is reachable for students to solve that problem. Yeah. Recently, I came across, I think, the Jobs of 2025 report or something like that. And then one of the top skills that we teach students is persistence and resilience in the face of uncertainty, right? And PBL has so much uncertainties in terms of what knowledge is required, what solution is required, right? And what's the path to take. So this is an ecosystem wherein persistence and resilience comes into a system. That's the first upside of this, right? One second would be the students are able, this is a very broad level thing, but coming down to the basics of it, PBL helps us see integration across courses, and knowledge doesn't exist in silos anymore. So this is the second of it. If you look at literature, there is lots of advantages of PBL which have been spoken about very voraciously. You could speak about critical thinking, analytical thinking. I don't want to go into all of those, but top things I see is resilience, persistence, and the ability to connect knowledge across courses and see them as not something which work in silos, but cut across their programs and schools. So that is the biggest upside of PBL. So if I look at it, at the bottommost, first year engineering or first semester, and we go all the way till the final year, right? So this is the trajectory of it. Now, what problems to take at every year? Well, that is a question of debate. We could have integration at modules or courses. We could have integration across semesters. So we have a dependency of course X and course Y, a problem that requires both. Or you could also have a theme, say sustainability or smart cities at a program level, and identify problems around it. So this also brings in the elements of interdisciplinarity. That is where it comes down to. So we could have students coming from different schools contributing to it, or different schools contributing, different programs contributing to it. But this actually requires, like you rightly pointed out, huge effort from faculty members. Students don't see the duck waddling under the water. They see a very seamless movement of courses. But whatever battling happens, it's the faculty to be bearing it. I think at my level, because I interact with people, that is either faculty or students, from students there will be resistance, but nothing which cannot be overcome. The biggest challenge or resistance comes from faculty members because of the extra time, the effort that they have to invest, not just in creating a PBL content, but delivering it, assessing it, and again reiterating it for revisions the next semester. And what are the incentives for doing it? Right? This is where it comes down to. So creating a PBL ecosystem requires a team of faculty members. And yeah, I think that's the only challenge I see. There are several others, but this is something without incentivizing a faculty's contribution to PBL ecosystems, it's difficult to buy them in on long term. Assessment is one of the very challenging aspects of PBL, because when I look at PBL, students work in a team. There is a problem domain, there is a solution domain. So a student requires both understanding of the problem, what the problem is, its objectives, functions and constraints. You also have a method of implementing it, the process knowledge, and you also have the if it's a hardware project, it also has the know-how about how certain sensors or some actuators would work, right? When I look at all of these together, I think assessment becomes challenging because we have to assess students at both levels, individual, team, as well as team artifacts, team outputs. So all these three bring a harmony into our assessment. So I could probably conduct a Viva at the individual level for like say 6 marks or something. 4 marks could go for the team outputs. Now if I look at one of the PBL artifacts is a group project, is what we commonly talk about. But now with LLMs in picture, the project report will come out in like 5 minutes. It's done, right? So I think right now we should majorly emphasize on what the students know by looking at a Viva-based as way of assessing them, and then the team outputs. So I think I would go in for, now with my maturity of doing it and the current age of how AI is influencing education, I would go in for a higher weightage for individual assessment than for team outputs, unless until the output is a project, a larger project, so that is where it comes into picture. I wouldn't really assess their project reports. It's just like a waste of spending our time, because I would give inputs on the project report, they would go and ask ChatGPT for it, again get me the inputs. So it's just a waste of time. So I think individual assessment and team level assessments would really help us iron out the accountability issues in PBL. So and that's when the grades gets decided. And we can actually maybe address the problem of free riders to a large extent. But again, that requires a lot of faculty time and effort. Imagine spending like 20 minutes on a team's assessment. So there are built-in mechanisms of, including the assessments as a part of a semester plan. So in PBL, we don't have to teach all the content, identify the exemplary content that is required. By exemplary, I mean the core content that can be that is very essentially required in a particular course. For example, if you have say a calculus, so what are the core things students have to know, must do, can do, and could do. So could do is keep it out, they could learn on their own, but the core part is where we focus on. So in a way, PBL requires shedding the content to a exemplarity, just the bare minimum that's required, and helping them apply to different contexts, so that the burden of assessment can be reduced.